All right, Honor. So this is the extra assignment from 8.3 on Delta Math. So I wanted to do two things in this video just to kind of extend your learning. Again, I expect you guys will take pre-calc as, possibly juniors or seniors. So again, helpful to know this stuff ahead of time. So first off, when we talk about 45, 45, 90 triangles. See, the 45-degree angle is a very important angle that you'll learn later in mathematics. And we use it so often that we have a unit circle devoted to the sine, cosine, and tangent values of a 45-degree angle. So I want to find the value of the sine, cosine, and tangent of this 45-degree angle. So I'm going to label this picture. So S is the opposite side. Here's my right angle. So then S squared root of 2 is the hypotenuse. And then S is the adjacent. And again, you might be concerned that there's S's, but all three sides have an S, so they will simplify fine, okay? So again, don't forget about your SOHCAHTOA. SOHCAHTOA. Okay, so let's find the sine of 45 degrees. So the sine of 45 degrees is equal to the opposite side, S, over the hypotenuse, S squared root of 2. Well, the s's will cancel, leaving a 1 on the top, 1 over the square root of 2. And we do not leave the square root of 2 in the bottom. We need to rationalize this by multiplying top and bottom by the square root of 2. And the top becomes just the square root of 2, and the bottom, remember when we rationalize, the 2 pops out of the square root. And this is the sine of 45 degrees. Square root of 2 out of 2. Always and forever. Always and forever. Cosine of 45 degrees. Well, cosine is adjacent over hypotenuse. So it's the exact same thing, right? So we can go through this whole process or just streamline it to, it's going to become the square root of 2 over 2. The cosine is the same as the sine. That's very nice about 45. Maybe it's because it's a isosceles triangle, right? 45, 45, 90. Now what about the tangent? What's the tangent of 45? Well, tangent is opposite over adjacent. Opposite is S. Adjacent is S. What? S over S cancel. That's equal to 1. And that's what the tangent of 45 degrees is. The tangent of 45 degrees equals 1. So again, you'll talk about these values later on in pre-calc, but I just want to kind of give you a heads up and maybe connect section 8.2 to 8.3. So now let's do the same thing with the 30, 60, 90. Now again, the 30, 60, 90 is a step up because there are two angles. Okay, so for the 30-degree angle, opposite side is S. Hypotenuse is 2S. And then the adjacent side is S squared root of 3. So to find the sine of 30 degrees, I need the opposite S over the hypotenuse 2S. Well, the S's cancel. That is 1/2. So that is equal to the sine of 30 degrees. Now, we should know that without doing anything, the sine of 30 is going to equal the cosine of 60 degrees. You should know that, right? That's from last lesson we talked about complementary angles in a right triangle. We actually talked about it in the first video of 8.3. Okay. What about the cosine of 30 degrees? Well, the cosine is equal to adjacent over hypotenuse. Again, the s's will cancel, and that does not simplify. That's the square root of 3 over 2. And that is equal to the cosine of 30 degrees, which we should know is going to be equal to the sine of 60 degrees. And now what about the tangent of 30 degrees? Well, the tangent of 30 is equal to the opposite s over the adjacent s square root of 3. Now the s's cancel, but it leaves a 1 on top. So that's 1 over the square root of 3. We do something very similar with the 45-degree angle. We rationalize, and we're going to get the square root of 3 over 3. And that's what the tangent of 30 degrees is. Now, to get the tangent of 60 degrees, I'm going to quickly just flip this original fraction upside down, because when you do 60 degrees, now s square root of 3 is the opposite, and s is my adjacent. So from 60 degrees, you have the opposite s square root of 3 over the adjacent s. And now here the s's just cancel, and the answer is just the square root of 3. and that's the tangent of 60 degrees. They are still reciprocals of each other, but again, because of the rationalization, they look a little different. Okay, so again, just trying to tie in, your trigonometry with your special angle values, 30, 45, and 60 degrees. And again, hopefully this just rings a bell when you reach it in pre-calc. The last thing. So we have talked about sine, cosine, and tangent, but there are also what we call reciprocal trigonometric ratios. So aside from the sine, cosine, and tangent, we have things called the cosecant, the secant, and the cotangent. Cosecant, secant, and the cotangent. And they are just the reciprocals of your sine, cosine, and tangent. So let us focus on angle A here. So from angle A, 12 is your opposite. The right angle points to 15, which is your hypotenuse. And that makes 9 your adjacent. So what would be the sine of A? Well, the sine of A would be opposite 12 over hypotenuse 15. But the cosecant of A would be the reciprocal of this, 15 over 12. So see how they relate. The cosine of A would be adjacent over hypotenuse, 9 over 15. So what would the secant of A be? Well, it would be the reciprocal, 15 over 9. And then the tangent of A would be opposite over adjacent. Well, the cotangent of A is the reciprocal, 9 over 12. So this is how I think the easiest way, right? Use your first three to get whatever ratio it is, and then just take the reciprocal. So in delta math, there is a 6 trig ratio assignment. So I'm going to do one or two of them involving these guys. All right, so here it is. So it says in triangle QRS, the measure of angle S is 90, RQ is 41, QS is 40, SR is 9. What ratio represents the cosecant of Q? So the first thing I would do is just make sure you know where Q is and what the cosecant is related to. So cosecant, S or CSC, is related to sine. So you must first find the sine of angle Q. Well, sine is opposite over hypotenuse. So from Q, 9 is your opposite. And then the right angle points to your hypotenuse, which is 41. Sorry about the delta math and the delay. So the sine of Q would be the opposite 9 over the hypotenuse 41. So then for the cosecant, you're going to take the reciprocal of that. So the cosecant of Q is going to be 41 over 9. And there we go. 41 over 9. So come down here. 41 divided by 9. So my answer. Oh, yeah. And then let me just show you the high-speed ones again, the quick pace ones. So again, these are the timed ones. You have to do 10 again. So if I'm starting here, so I want to do the secant of A. So again, if I'm just slowing it down, so the secant of A is related to the cosine of A. So if I find the cosine of A, which is ca, right, adjacent over hypotenuse. So from A, 24 is the opposite, 51 is the hypotenuse. That makes 45 the adjacent. So the cosine would be 45 over 51. But I know that secant is the reciprocal. So I'm going to choose the reciprocal of 45 over 51, which is 51 over 45. And there it goes, counts to 1. Remember, when you get to the end, once you see 10 out of 10, you may stop. And I think if you get one wrong, it starts you over. So don't get one wrong. All right, but again, these are the reciprocal trig ratios. All right, have fun.